All right, guys, so let's get started here. Let me check if the volume is working. Is this working or not? Yeah, it looks like it's working. All right. So this will be page 9, lecture 2. Okay, so we're going to do a problem, which is to, so example, is to determine the equation of the plane that contains the 2 points, so that contains the points, actually there's 3 points, okay, P equal to 1 minus 2, 0, Q 3, 1, 4, and R 0, negative 1, 2. Okay, so I think always figures help a lot in order to understand the problem. So we need to determine the equation of a plane. Let's say this will be your plane. All right, this will be the plane that we need to find the equation. And let's say you have 3 points over here, which will be whatever, P, Q, and R. Okay, and if you remember last time, in order to find the equation for 2 points, you were assuming that you had a perpendicular vector to the plane, no? So that's why we need 3 points actually in order to find n. So in order to find the equation of the plane, we need to know basically one vector and the vector n. Okay, so if we know 3 points, what would be the way to find the vector n perpendicular? We know that if you use the cross product, what is the result of the cross product? Let's say we have PQ and PR. If we do PQ times PR, the resultant will be a vector that is perpendicular to the other two, no? So that way we can get n. All right? So let's do that first. So let us find n. So let's say over here that the normal vector, normal perpendicular vector, and we can find it by doing what? We can say that n, let's say would be equal, but you can do a different one, but let's say we do PQ, vector PQ cross PR. Okay? And if you do this one, the resultant of the cross product should be a third one that is perpendicular to the other two. So PQ, PR, no? Okay, so what would be PQ? PQ will be equal to 3 minus 1, 2, 1 minus 2, 3, and 4 minus 0, 4. And PR, similarly, would be equal to what? 0, 0 minus 1, negative 1, will be minus 1, minus 2 will be plus 1, and the line will be 2 minus 0 should be 2. Okay? So we're going to do the cross product the easy way, which is to use the matrix form. So we're going to have I, J, K. Then we can have here the vector PQ, which is 2, 3, 4. And then the PR will be -1, 1, 2. So we do the cross product. Well, you get to the first one, you will get 3 times 2, 6, -4, 2. Now the next one, you know, will be initially negative, no? But you have 2 times 2 minus -4 will be 8, but because of the negative sign, should be -8. And the last one will be 2 times -3 would be 5. I mean, you don't have to, but if you want, you can normalize this vector, okay? But you don't have to normalize it, okay? Okay, so now you can choose which of these points you want the plane to go through. Okay, you can choose either P, Q, and R, okay? But in this case, let's just say using P, which is equal to 1 minus 2, 0, and a general point on the plane with coordinates x, y, and z. We need to introduce x, y, and z because the equation needs to be in function of x, y, and z, no? Okay. All right. So then, in this case, you're going to have that. Let me go to the next page. Maybe before I go to the next page, let me stay over here. What was the general equation of a plane? Referring the plane, if you remember, we say it needs to be equal to n dot r will be equal to 0. Okay, that was the definition of the plane. Okay, so we found n, now we need to find r. Okay, so basically r will be from P to the relative point. Okay. Okay, so from here we're going to find that r will be equal to what? X minus 1, y plus 2, remember it's from point P, and z minus 0. Okay, so the equation of the plane, which we know is given by the equation n dot r equal to 0, will be equal to what? We found n to be equal to 2 negative 8.5. We're going to have, so n dot r equal to 0 will give you 2 negative 8.5 times r, which is from point P to a relative point. You could do Q to a relative point or r from the relative point. R is right here, so it's x minus 1, y plus 2, and z. this should be equal to 0. So what is this? If you do the dot product, what are you going to get? You're going to get 2 times x minus 1 minus 8 y plus 2 plus 5z. So this will be the equation of the plane, or we can just rewrite it as 2x minus 8y plus 5z. And let's see what will be the constants. Will be -2, -16, no? If we move it to the other side, we have here 18. So you can use either one, but basically this will be the equation of plane through the 3 points. Okay? I remember that all this is important later on, because when you go to the stresses, you want maybe to find the stresses at a certain angle on the solid, no? So you need to know how to manipulate all this stuff over here. All right, let's do another problem, and that'll probably be the last one for this. Let me go to another page, so continuous. Next page. Okay, so 11 will be another exercise or example. Determine if the plane given by minus x plus 2z equal 10 and the line vector r, which is given the parametric form 5, 2 minus t, 10 plus 4t. I will explain this after the problem. R orthogonal parallel or neither one. So basically, if we had to plot it, let's say we have a reference frame x, y, z, and let's say you have a plane over here. Okay, where you have, let's say, your vector n. This is your plane, and you might have here the point, let's say R1, so R2, R1, I do it this way. So it will be the R, no? So, I mean, you have different options. They can be, these two can be parallel to each other, no? Can be perpendicular, or probably the bigger chance is that they're either one, no? That's why you have the bigger chance. So how can you check that? All right? So again, what would be the way to do that? First thing would be to find the equation of the plane, the equation of the curve, and then using either the dot product or the cross product, we can find if they are parallel or perpendicular to each other. Okay, so it's always the same procedure. So let us first find the equation of the plane, which would be this one over here, plane. So the equation of the plane we derived last time, we know will be given by n dot r must be equal to 0. Okay? So in this case, let us say that the normal vector n, we don't know what it is, will be given by some coordinates ABC. Okay? And r is a general form. This is what we derived the first day. Let's say will be between 2 points, one of coordinate x, the other one of coordinate bar, x bar. So it will be x minus x bar, y minus y bar, z minus z bar. All right? So the equation of the plane is n dot r equal to 0. Basically, what we're just doing here is to write down the most general form of the equation of the plane. So we do that, we're going to have a, b, c dot x minus x bar, y minus y bar, z minus z bar. So if I expand that, this would just give you a times x minus x bar plus b times y minus y bar plus c z minus z bar equal to 0. Okay, but remember, here we have the equation of the plane, no? Yeah. So let's say comparing above equation with the equation of the plane, which is minus x plus 2z equal 10. What are you going to have? N, which is equal to a b c, will be equal to what? A will be equal to near 1. Okay. B will be equal to 0. And z will be equal to 2. All right. You do not have to do all this stuff, but for the first time, I'll show you the way it's coming from, no? But if once you have experience, you can just go straight from here to here. All right. So we know n. Okay, now we need to find the vector r, which is r1, r2. So what we need to define, this is a parametric form, we need to define 2 points, okay? So in order to define 2 points, this is in function of t, we can just take 2 different values for t, okay? And that will give us one value for, let's say, t equal to 0, and for t equal to 1, we get another point, okay? You can use either values you want. Okay, so we need to find, so let's say at t equals 0, you're gonna have that r1 will be equal to what? Will be 5, I just rewrite it, 2 minus t, 10 plus 14, no? Just writing in different forms, so at t equals 0, this will give you what? R1 will be equal to 5, 2, and 10. Okay? And let's say that at t equal 1, we're going to get R2 equal to 5, 2 minus t, t plus 4t, which will give you R2 equal to 5, 1, and 14. Okay? So now I will look at the figure over here. So we call it R bar. Okay, that's fine. So I'm going to have that R bar. Then R bar is basically a distance between the vector of the 2 points R1, R2, no? Okay. So what would that give us? You will have here, yeah, let's do it by detail. 5 minus 5, 1. No, 5, 5, 1 minus 2, and 14 minus 10, no? So basically we get that our vector R here would be equal to 0, -1, 4. Okay, so now let me switch to blue maybe. So recalling, and from the previous page, n is equal to -1, 0, and 2. Okay? What do we have? If n, and let's say the vector r are parallel, how can we define that? Do we use the dot product or the cross product? The cross product, you have n cross r bars should be equal to 0. Okay? So if we do that calculation, what do we get? We're going to do the cross product. So let's use the matrix I, J, K. Of n, which is -1, 0, 2, and r, which is 0, -1, and 4. And this will give you what? So it gives you 0, minus 2. Okay, so we already know it's going to be different than 0. We should stop over here, but let's do the other one. Then I'll give you what? -4, but it's negative, will be 4, no? Then will be 1, -0, 1. But what's important here is to see what? Is that this will be different than 0, no? So what is the conclusion? N and R are not parallel. Okay? So now the next thing we need to see if they are perpendicular. So if N is perpendicular to R, then this time will be the dot product. We have N dot R should be equal to 0. Okay? So we do the calculation. What do we get? So N is equal to -1, 0, 2, dot R, which is 0, -1, 4. Okay? And this will give you what? 0 plus 0 plus 8, which once again, this is different than 0. So what will be the conclusion? And V, N, and R, sorry, are not perpendicular. So you are correct. That means then that the vector r will be cutting, if you want, the projection of the vector r would be cutting at angle the plane. Okay, so the next thing I'm going to define here, maybe I should have done it before the previous example, is what is the equation of line in parametric form. Okay, so basically it's the same thing that we just did. So you have here, just to change a bit, I'm going to use x1, x2, x3 instead of x, y, z. Let's say it would be r sub naught, the point r sub naught. This will be r. And let's say we need to find the direction of this one would be n, the direction vector along the line. This is what I called before r, okay? But here I just call it n or r, whatever you want. So what do we know over here? Let's say that r sub naught here will be equal to x sub naught, y sub naught, z sub naught, and that r over here will be, the point would be x, y, z. So the vector r, vector r this is the definition, would be equal to r naught plus nt. So for example, what is the definition of a straight line? Is y equal a plus bx, no? Yeah? Basically, this is exactly the same thing. Or here you can find, or this will mean that x will be equal to x naught plus n 1t, because this will be the one, let me put here, n equal to n1, n2, n3. Or y will be equal to y sub naught plus n to t, and z will be equal to z sub naught plus n3t. Okay, so this is the normal form of the equation of a line. Yeah, vector, this is line equation. Y equal ax plus b. Okay, now if I want to put it into parametric form, what do you do? So it's very simple. What is the variable that is common to all three equations? Is t, which will be equivalent to the slope, no? Okay, so you can say t. So if you look at the first equation, what you get for t will be equal to x minus x sub naught divided by n1. Or this will also be equal to what? Y minus y sub naught divided by n2. Or this will be equal to z minus z sub naught divided by n3. Okay, so here you see that the value t is given, following your question, by an infinite number of points along the line, no? Your x sub naught, they say it's fixed, but the x can be any point, no? Yeah? And it will be in function of t. That makes sense or no? All right, so there we go. So now we're going to look at the initial notation, which basically is what you were just referring to. Okay, so the first one we're going to look is something called the Kronecker delta operator. Okay, and this one is pretty simple. It's based basically on rotation of the coordinate axis. So imagine you have your coordinate axis. Instead of calling A, X, Y, Z, we're going to call it, or I, J, K, we're going to call this one E1. So this is a unit direction vector, no? E1, E2, E3. And basically, from dot product definition, what do you have? U dot V equal to UV cos of the angle between the two vectors. No, we did it the other day. So now let's say that U can be either E1, E2, E3, and V can be either E1, E2, or E3, okay? So we do that, what do you have? So you know this one will be a Cartesian system, so they are perpendicular. So if you do E1, so EI, let's do 1 or 2, let's say E1 dot E2, what would that give you? The angle is 90, no? So this will give you 0. If you do E1 dot E3, this will also be equal to 0, no? Okay. Now what happens if you do, let's say, E1 with E1? This will give you 1. Yeah? Okay. So if you want this way, okay, you can do all of them if you want. E2 will be 1, E3 will be 1, no? And so on, so on. So at the end, what you can find is that, or you could just write that E of an index I dot E of an index J will be equal to 0 if I is what? Is different than J, no? 1, 2, 1, 3, 2, 3, 3, 1, so on. Or you could rewrite that E dot I dot product E dot J will be equal to 1 if I equal to J. All right? So introducing the notation delta ij equal to ei dot product ij what would that give you? Delta ij will be equal to 1 if I equal j, and delta ij will be different than, sorry, will be equal to 0 if I different than j. And this is basically the definition of the delta chronometer. So you see that really the origin of this is based on the rotation of the coordinate axis, no? But for simplification, somebody wanted to call it delta chronometer. Over here. All right, so let's look maybe at some examples over here. Quick example. So what would be then if you write down delta II? Remember before, what did we say? If you have repetitive indexes, you need to put all the numbers, no? So this one would be equal to what? Delta 1 plus delta 2 plus delta 3. Okay? And this will be equal to what? 1 plus 1 plus 1 equal to 3. Okay? Let's do another one. Okay, so the other one will be if you do delta ij ej. So again, let's first rewrite into a different form. Let's first, which one is repeated over here? Is j, no? So I could write this as delta I1 E1 plus delta I2 E2 plus delta I3 E3. So now I repeated all of them. Okay? So now, if I do the same thing, if I equal to 1, what will you have? So you have 1 plus 0 plus 0. Okay? Now if I equal to 2, so it will be 1 plus 0 plus 0. This will be for I equal to 1, no? Then what happens if the I is equal to 2? You will have 0 plus 1 plus 0, no? Or I equal to 2. And then here you have what? 0 plus 0 plus 1 if I was equal to 3. Okay? So really, at the end, this is equal to what? 1 plus 1 plus 1 is also equal to 3. Yeah? Okay, so different notation, no? Okay, so over here, let's say, so let me do the correction over here. So it should be then E1, E2, E3, or this should just be equal to E sub I, okay? Or if you want, let me do here very quick proof again. We could just say delta Ij, Ej is equal to what? Ei, Ej times Ej. You could write this as Ei of Ej dot Ej, which will be equal to 1. Yeah? Or this would just be equal to Ei, but Ei could be the same thing as Ej. Okay, so we'll get the same thing. Okay? So now we get E1, E2, E3. So this is our place from the class note. This is another one. All right. So now we're going to do the dot product. Using indicial notation. Which is what we just did, really, but okay, so let's say we get two vectors, u dot v. Okay, so this is the same thing. A vector has magnitude and direction, no? So let's say we write u as u sub I magnitude, e hat I direction. And we rewrite v as v, but this time sub j, e sub j, so magnitude times direction. So this will give us what? U sub I, v sub j. So basically you take the magnitude, no? Okay? And now you do this one of e sub I dot e sub j, which is equal to what? This is equal to u sub I, v sub j, times the delta Kronecker ij, no? Over here. So now, what is the definition of the delta Kronecker ij? If I is different than j, you had it was equal to 0, no? Okay? But if I equal j, so here you can put if so equal to 0 when I different than j, okay? Plus what? Plus if you want u sub I, v sub I, delta I will be when either j equal y or y equal j, no? Yeah, understand the two parts over here? So, I mean, at the end of the day, so what are you gonna have? You're gonna have that u dot v, and this should be equal to 1. So at the end of the day, what you're gonna get, this is equal really to u sub I, v sub I, no? Which should just give you a magnitude, no vectors. So this time we are good, no? Yeah. Okay. So to see some of the indicial notation, let's just write out one expression that we'll be using later on, so it's not a problem to write it down. So example, write out the equation partial derivative of, really should be the vectors with respect to j plus b sub I equal rho a sub I. Okay, so here I'm going to stop the video for a second and see if you can write it down on your own, and then we do it together. Okay, so over here, which one is the repeated index? Is the j. So j is repeated. You need to do the summation about the j. So here what you can write is just the partial of sigma of, let's say, I1. You divide that by x1 plus the partial of sigma I2 with respect to x2 plus the partial of sigma I3 partial with respect to x3. So you leave b sub I because it's I untouched equal to rho a sub I. So this is really the only difficult one to write down, okay? Now what you need to do is to give the values 1, 2, and 3 to the I. So basically that means that from this equation, we're gonna end up with 3 equations that will be what? Partial sigma 1, 1, x1 plus partial sigma 1, 2, x2 plus partial sigma 1, 3, x3 plus b1 rho a1. This would be one equation. So the equation will be partial of sigma 2, 1 partial x1 plus partial sigma 2, 2 x2 plus partial sigma 2, 3 x3 plus b2 equal to rho a2. And the last one will be partial sigma 3, 1 x1 plus partial sigma 3, 2 x2 plus partial sigma 3, 3 x3 plus b3 will be equal to rho a3. So really you have 3 equations, okay? This will be for a control volume like the summation of forces on the x, y, and z, okay? But this would be like forces due to stresses. This would be the outside forces, okay? Whatever. But you see in the indirect notation, you end up with this type of expression. Okay, last thing I'm going to cover today is just the epsilon operator, which is the permutation symbol operator. All right, so next we're going to look at the permutation operator, which is the epsilon operator. So basically, this is what we have. We have epsilon of ijk will be equal to either 1, -1, or 0. So it's equal to 1 if I, j, k are clockwise. So basically, it's the little circle I did the other day. If you put here I, j, k, no? So if it's a clockwise rotation, so what you could have? I, j, k will be 1, j, k, 1 will be 1, okay? And so on. Will be negative if it goes counterclockwise. Counterclockwise. or 0 if it's any other combination. So basically, you cannot have I, or cannot have it can be 1, 2, 3, 3 to 1, but all the combination will be 0, no? That's what I'm saying. Okay, so doing this permutation operator, you can see that when you do the cross product, or the cross product of different vectors, you can simplify the notation just by using that symbol over here. Okay, so we do examples next time. All right.